Hi everyone and welcome to the internet. What we're going to be doing in today's chemistry lesson is having a look at different electronic structures and how we draw them. So hopefully by the end of this you'll be able to draw these and describe what they actually show us. To start off though, 3 questions based around our previous lesson, so have a go at answering these 3 questions in your book. I'm going to give you about 3 minutes to do that today. So first one, the physical properties of our metals then. You can have any 3 of the following, so give yourself a tick for each one you got. Shiny, high melting point, high boiling point, solid, malleable, ductile, good conductor of heat, good conductor of electricity. So maximum of 3 marks for that one. Then same thing for our non-metal physical properties, again a maximum of 3 marks, 1 for each one you get. Dull, low melting point, low boiling point, brittle, non-ductile, poor conductor of heat, poor conductor of electricity. And the final one, how do we work out the chemical properties? Then the answer is we study the chemical reactions. Give yourself a tick if you got that one. Add up your score, it's out of 7 today, and write that in your books for me. What we're going to do first of all then is just think about some bits that I'm hoping you covered back in Key Stage 3. So what I want you to do is tell me where we find periods and groups on the periodic table, and then what can you say about the chemical properties of elements in the same group. So I'm just going to give you about 2 minutes to answer that. So we find periods as the horizontal rows on the periodic table, so they're the ones that run from left to right. The groups are the vertical columns, the ones that go from top to bottom. And in terms of what we can say about the chemical properties of elements in the same group, then they've got similar chemical properties. So any element in that same group will have similar chemical properties. So obviously tick any of those you got right and give yourself a mark out of 3. If you didn't get anything right there, make sure you do correct your work so you know where we find periods, where we find groups, and what we can say about chemical properties of those elements in a particular group. Hopefully something that's a nice little bit of a recap for you. I'd like you to describe in words the structure of an atom. And just in case you need a bit of a hint, there's a rather big one at the top of the screen there with our diagram. So just going to give you a couple of minutes to describe the structure of an atom for me. Hopefully what we said is that we have a nucleus which is made of protons and neutrons, and that nucleus, as we can see in the diagram, is located in the centre of our atom. And that nucleus of the protons and the neutrons is surrounded by these shells that contain the electrons. So the 3 subatomic particles, proton, neutron and electron, protons and neutrons in the nucleus in the centre of the atom, and then the electrons found in those shells or orbitals around the nucleus. What we're going to be focusing primarily on in today's lesson then is how we can draw these electronic structures. Now, when we talk about the electronic structure, what we're referring to is the arrangement of the electrons within an atom. So what we're actually going to be doing is looking at different atoms and seeing how those electrons are arranged within their structure. One key term we really need to know, aside from electronic structure of course, is outer shell. So as we've described where we've looked at the structure of an atom, then the electrons are arranged in shells around the nucleus. Now the outer shell is the one that is the outermost occupied shell. So basically what we find is the electrons start, so to speak, from the centre and then they build up. The more there are, the further out we go, the more shells we get. So what we find is that the outermost shell with electrons in it, that is the outer shell. So just be familiar with that term. before we can go any further, we need to learn some rules. So this is one of the reasons that I really love chemistry, is because if you know the rules, then a lot of it becomes quite easy to do. So our rules for electronic structure that we must remember. First one is that in the first shell, so the shell closest to the nucleus, we can have up to a maximum of 2 electrons. So you can have 1 or 2 electrons in that shell. The second shell, so the next one out, that can hold a maximum of 8 electrons. The third shell is a maximum of 8 electrons. And the fourth shell can hold up to 18 electrons. As far as your exam paper is concerned, then you basically need to remember 2, 8, 8. So 2 for the first, 8 for the second, 8 for the third. And then anything else that didn't fit into those first 3 goes into the fourth. So they're never going to ask you to go above the fourth shell, I can promise you that. Generally speaking, you're going to be playing with 2 or 3 shells of electrons. So make sure you've got those rules written down, make sure they're in a box highlighted, done in a different colour, something that makes them stand out, because they are very important. Because if you don't know these, a lot of things go horribly wrong. So I'll leave these up for another minute to give you a chance to get that done. So when it comes to drawing the electronic structure then, the first thing we need to do is look at our periodic table. So what we do is we're going to find lithium, in this case, on the periodic table, which we find in group 1, far left hand side, and we need to look at the atomic number. Now the atomic number of lithium is 3. So because the atomic number is 3, that tells us it has 3 electrons. Now what we're going to do then is we start off with our lithium, and we draw the first shell, the one closest to the nucleus. Now this one can hold up to a maximum of 2 electrons, and what we do is we draw those in with a cross. So we've already used 2 electrons, but that's all that shell can hold, and we need 3. So we still have 1 more electron to go, so we need to add our second shell, and then we put our electron in there. So that's it, that's our actual diagram. We've got 2 electrons on the first shell, 1 on the second shell. That gives us our 3 in total. The last thing we need to do is we actually need to write our electronic configuration, which we just do as 2.1. So all you do is the number of electrons on the first shell, a dot, number of electrons on the second shell. If needed, then we go on to another dot, and the number in the third shell, and so on. And that's all we need to do to draw the electronic structures. So periodic table, look up the atomic number, up to 2 electrons in the first shell, then up to 8 in the second, and so on, and then finally write the numbers of each electron in each shell at the bottom, separated by dots, and that gives you your electronic structure for any of the elements. Okay, so here's your challenge then. What I want you to try and do is, we've seen how to do this with lithium. I want you to try and work out the electronic structures of as many of the first 20 elements on the periodic table as you can. So that's atomic numbers 1 to 20. Now, if you've actually got that, see if you can spot anything about the patterns in those electronic structures. Now, I'm going to give you a very nice 7 minutes to have a go at this. So you've got 7 minutes, hopefully you've got a periodic table handy. If not, then obviously just hit pause for now and then just grab one on the internet. Write out the electronic structure, so do the diagram, And then don't forget to write your numbers at the bottom as well. So you need the 2 parts of it. So 7 minutes, do as many as you can. Good luck. Hopefully, we've got something like this. So if you start in the top left corner, you can see hydrogen, 1 shell, 1 electron on it, and therefore just 1. Helium on the far right there has 2 electrons, therefore 1 shell with 2 electrons on it, and just the number 2. On lithium, we already saw that one, 2.1. Beryllium has got 4 electrons, so 2 on the first, 2 on the second, and so on. We just keep adding 1 on. Now, that's the first 20 on there, so you can have a look and mark these. In terms of how we actually managed to spot any patterns, then what you may have said is that as we work from atomic number 1 through to 20, then we just add 1 more electron. Because we are. The atomic number is the number of electrons, and if we're going from 1 to 20, we add 1 more electron each time we go. But if we look at the groups, so the vertical columns, starting on that far left-hand side, you may notice that we've got 1 as the last number in each electronic structure, and that is group 1 on the periodic table. If we go to the second column, they all have a 2 as the last number, so 2 electrons in their outer shell, and they're group 2. Same for group 3, 3 electrons, and even when we get all the way to group 6 with oxygen and sulfur there, 6 electrons in their outer shell. 7, the halogens, they've got 7 electrons in their outer shell. So what we can actually see is that that last number in its electronic structure, or that we could describe it as the number of electrons in the outer shell, is the same as the group number. So I'm going to leave this up just for another minute so you can obviously mark any of yours that you managed to get through. Obviously give yourself a score out of 20 for the electronic structures that you managed to do, and make sure if you did write down about the patterns that you've marked if you got that right as well. So based on those patterns, see if you can fill out what each of these 3 things represent. So the last number in the electronic structure, the number of numbers, so how many numbers there are, see if you can spot a pattern for that one, and the sum of those numbers. So if we add those numbers in the electronic structure together, what do we get? So I'm going to give you just a minute to have a go at this. So that last number, the final number in the electronic structure, that is the group number. The number of numbers, so how many numbers make up that electronic structure, that tells us the period. And the sum of the numbers, if we add them all together, we have the atomic number, which is also the number of electrons present. So tick any you got right, and obviously any others that you either didn't get right or missed out, make sure you've got them written down, because this is really important on some of the questions they could ask us. Because one of the things they do like to do is they will give you an electronic structure and then they'll ask you what group and what period is it in. Or they will give you something to do with the periodic table or its electronic structure, and they will ask you what you can work out about it. And they're looking for things like the group number, the period number, and so forth. Let's just have a little look to see that in practice. So what I've given you in the diagram there is potassium. So we've got the electronic structure, or the electronic configuration they sometimes refer to as, for potassium. So we actually find that potassium has a grand total of 19 electrons. Its atomic number is 19. So we start off with 2 on our first shell closest to the nucleus, because that can only hold up to 2, 8 on the second, 8 on the third, and then we're left with 1 on our fourth shell. So its structure is 2.8.8.1. Now that last number, the 1, tells us that it is in group 1. Because it's a 1 there, 1 electron in the outer shell, it is in group 1. If we look, 2.8.8.1, there are 4 numbers there. Therefore, that's in the 4th period, so the 4th row across the periodic table. And then if we add 2, 8, 8 and 1 together, we get 19, which is the atomic number. So that gives us that 3 bits of information about potassium just from that one either little string of numbers or diagram. So remember, the last number is the group number, the number of numbers is the period, and the sum of the numbers is your atomic number. So last thing for today then is the plenary. So those of you with target grades up to grade 5, it's the column on the left. Those of you with target grades over grade 5, it's the column on the right. So I'm going to leave this up for about 3 minutes today, but obviously, as always, if you need longer, just hit pause and take as long as you need to do it.